everyone, in this video for Algebra 1, we're going to talk about Euler's equation. So let me talk about Euler for a few minutes. So Euler is noted with Euler's number, which is E, and you'll learn all about that when you start learning about logs in Algebra 2. We're going to keep it simple. And I'll just tell you a little bit about the world of math that he lived in. He mainly worked with trigonometry. He comes up with a lot of really good trigonometry concepts that we even hold true today. And he uses a lot of geometry to trigonometry, kind of bridging that gap between the other maths and trigonometry. And he accomplishes a lot for the math world during his time. But one of the things he figured out was this really cool pattern with the vertices, the edges, and the faces of any three-dimensional shape. And mainly what we're looking at is polyhedrons when we think about three-dimensional shapes. So your regular polyhedrons would be a tetrahedron, a octahedron, a cube is a polyhedron. We have dodecahedron and isohedron. All right, and these are our main polyhedrons, and they all have vertices, which are points, and then their edges are where the sides come together, and then the faces are what we would traditionally call a side. Like when you have a six-sided dice, it has six sides. Those are the faces. All right, and what he found is this relationship always works no matter what. V minus E, the vertices minus the edges plus the faces, always equals 2. Okay? And it's really neat. No matter what polyhedron, three-sided shape you use, you're going to find this as long as it has faces, edges, and vertices in it. All right, so in this project there are 2 dice. One dice has 8 vertices and 6 sides, and the second one has 6 sides. Both dice have the same amount of edges, and we see that down here. This one has the same variable as this one missing. So obviously I got to solve for dice 1 first before I can do dice 2. So let's go ahead and put what we know into Euler's formula. So in this one we have 8 points, okay? That's what a vertice means. And we don't know how many edges, but we have 6 faces. Now, you might have already said, hey, I've heard of 6 faces before. Let me put another word in there. A 6-sided dice. What is a 6-sided dice? Well, let's go ahead and figure this out, and then I'll tell you. Let's get our like terms together. That is going to be a 14. Going to subtract 14 from both sides, so I can get this negative x by itself, and that's going to be a negative 12. Got to divide both sides by a negative 1, and in the end, we're going to get 12. 12 edges. And if you pick up any standard 6-sided dice, you're going to find that there are 8 points, there are 12 edges, and 6-sided, and it's 6-sided. So a 6-sided dice is a cube. We're looking at a cube, your standard 6-sided dice. Go into any gaming shop though and pick up any dice and pick up a bunch of dice, and you'll find this next shape. So now we know what this one is. It has 12 edges as well. So something with less vertices, okay, less than a square shape. Cube is square on all sides. So something that has less vertices than a square must have some sort of triangular relationship. All right, so think about your triangular shapes within your polyhedrons. We have 12 edges, and we don't know how many faces to this one. All right, so let's go ahead and put everything into our formula. Well, this is now a y. And we're going to get a negative 6 plus y equals 2. Going to add that 6 to both sides. Y is going to equal 8. What would we call an 8-sided shape? Well, in dice 2, what we have is an octahedron, a 6-sided shape. So octo means 8, hedron means a three-dimensional shape with sides and vertices. It's a special type of three-dimensional shape, not a sphere or any of those type. All right. Very good job, everyone. Keep learning about Euler. Maybe look them up. Maybe go to a game shop and pick up a bunch of dice and look at how cool they are and think about this relationship between their vertices, edges, and faces. I'll see you all in class, and I hope you had fun learning about Euler.